twice beyond these boundaries and so on and so forth. You might try to feed something that's not a number, right? Because maybe it's supposed to handle error conditions of the input coming in and it doesn't. Really depends on how the program was designed. So there's lots of different tests that you can throw at this thing. All right, so the last one that we're going to do before we break is iteration, right? So in the context of our example with the flow chart for frying an egg, we iterated whenever we checked and got the answer no for whether or not the egg was cooked to preference, right? So that means that you're doing some sort of looping, right? So you have this sequence. When you get to your decision point, somehow you go back to a previous step. It's called looping, right? And there's a lot of different ways that you can achieve looping in programs. There's for loops, there's while loops. You'll see different constructs. We won't get into too much detail on those. But the whole idea is that you will be stepping through and repeating steps for X amount of times, whatever X may be. So whichever your loop interval is. So here this says that, let's say that we have a list, that's our input, and we want to do for every item in that list, we want to do something, right? That's a general high-level loop structure. What could be wrong with iteration? Well, you have to think that whenever there's iteration, there is some set of variables that are being initialized prior to starting the loop, right? And then you start looping, there's some mechanism for keeping the loop going. All of these are points of failure, right? So, for example here, if we were testing something that loops, you would want to have a test that goes through the loop 0 times, right? To make sure that when we don't go through the loop, things still function as expected, right? Then you want to make sure you have a test that just goes through the loop just once, right? So in other words, it doesn't really loop, it treats it like a sequence, because that's a different path through the program. Then you want to have something that loops 2 times. And you can all write these down. The answers here are like 0, 1, and 2, right? So you want to have it loop twice, because that checks the reinitialization of the loop, right? As you go through, if you went through just once, you actually didn't exercise the loop. If you do 2 times, you not exercise the loop, right? And then remember that we want to always think about this white box testing from the perspective of the requirements. And so one of the questions that you can ask that's important is, what is the typical number of times that the user or whoever is consuming this function will iterate, right? Like if this is a shopping cart application, maybe the average user puts 5 items in the cart, right? And so 5 might be your typical number of iterations through that loop. You always want to make sure that when you're testing, that you think from the user's point of view and that you have what are the typical cases in there. And actually, I would argue that you want to make sure that the typical cases are the first set of tests that you do. Because as someone who's testing an application, yes, it's great to get creative and come up with all these edge cases. But the edge cases, while they're important for you to think about those, don't think that they're more important for you to start with than the typical cases. Because with testing, you always run out of time. And you want to make sure that when you run out of time, that whatever you've done is more important than the things that you haven't done. And if you ship that software and you haven't tested the normal path and there's a problem with it, then you're in trouble, right? So normally when I interview people or ask folks testing problems, I look to see if they're going to at least cover some of the basic positive scenarios first, right? The happy path, and then move on to getting creative. Because otherwise you can get very creative and then they're done and they haven't checked if the program did what it was supposed to do, not even once. And that is a big risk. Because what's the first thing the user is going to do? Not the edge cases sometimes. Sometimes they're going to just try to use it as it's intended to be used. And if they can't do that, then you failed as a tester. So another good thing is to have a typical case, right? I call it T, to just say, make sure you have a case that goes through the typical number of iterations for that loop. And then you can do max, and then above the max, right? So a lot of loop testing passes back to boundaries, but then you also can do the typical case. All right, so let's just summarize this, and then we'll take a break. The first thing is, code reviews can be very effective in finding defects. We saw that from a lot of the exercises that we just did. Looking at code allows you to perform more targeted testing. So we saw that we can look at specific values and actually test for those. When we looked at the national ID problem, and you're able to say, well, yes, we would have been able to see that if we didn't look at the code. Expectations that come from the requirements, not the code, right? You're still building something for someone, and so you have to go back to the requirements, because if you just look at what's there, you'll never miss what was not covered, right, and what the user expected. Tests should have discriminatory power, so we looked at the fact that some of the tests that we have, yeah, they weren't bad tests, but if the program was incorrect, the test wouldn't have revealed anything. And so stronger tests have this discriminatory power that they can differentiate. Once the program changes, the test has a likelihood of failing, right? You want to do just below, just above, and exactly on boundaries. This is nothing new to you guys. You already are, ISTQB certified and have all these testing techniques. That's just boundary testing. You want to try less than or equal to or greater than for relational. So we looked at the problem of having off by one errors. And so you want to make sure that when you're testing those conditions, that you're going one side equal to, and then to the right. And then we talked about our loops, that you want to do 0, 1, 2, typical, maximum, and maximum plus 1 times for loops, right? Any questions on what we covered so far? So that was pretty fun, right? So now we'll go take a break. I don't know how long the breaks are supposed to be. Do you guys know? Any clue? Should I just set how long it's supposed to be? All right. So what we can do is let's take a 15 to 20 minute break, right? Does that sound reasonable? Great. And then we'll come back, because then it'll probably take us about 5 or 10 more minutes to return to normal, and then we can start back up again, right? So we'll come back at, let's just say, 11:02. Right? Awesome. Thank you. Somehow, there's something wrong with the engine. How would you test that to tell me what's wrong with my engine? Testing course, right? I always ask you about testing. How are you going to figure out what's wrong with my engine? Pardon? The car won't start. The engine won't start. How do you figure out what's wrong with the engine?
The sound.
The sound? You listen? You must have very good ears. Very good ears, sir. I mean, if you can listen to my engine and tell me what's wrong with it, some people can. If some people have that skill, that means that you are a domain expert on engines. And I would take my car to you every single time if you do it that way. But typically, it's not so easy, right? You have to break things apart, especially very big, complex things. The best approach is to make sure that you look at the individual pieces that make them up, right? Because those individual pieces are the things that allow you to understand if the problem is isolated or if it's a connection problem between two things. And so this whole idea of unit testing that we're focusing on today, right? Because remember we did our testing by looking, which is a very good technique for finding defects and issues with code, which is our focus. But when it comes to actually doing unit testing, we want to get some techniques around unit testing. But first we have to understand the value that it brings. And typically, if you go back to this analogy, typically most cars are instrumented with these checks. You can have diagnostics, right? They could run diagnostics. And what those diagnostics are doing, it's just doing some small unit checks across. say, well, is this component up and running? Is this component up and running? And it does that, it comes back, and then you can see an error code, and the error code will tell you maybe where it failed, right? And so the purpose of doing testing in this manner is so that if you have your building blocks of your testing strategy, if you test the individual components, and they're working, and then you start to integrate and test the connections between components that should talk to each other, then you have a systematic way, starting from the bottom all the way to the full system, to pinpoint an issue. Because if you start running tests from the bottom and you start coming up, then you know, well, likelihood is, the chances that the problem is with the connection here, because all the other tests beneath it of the individual pieces were passing. But this connection test failed. And that's what unit testing is about, and that's why you have unit integration and then system level testing, right? And it provides a lot of value. One of the things that you'll hear a lot about is this idea of testing early, right? And you heard it from the beginning, right? Like, we want to test when requirements are being defined and so on and so forth, but you also want to test when that first piece of code is being written, right? As a developer touches the keyboard, I want him thinking about the requirements, and I want him thinking about how he can validate those requirements. I want him thinking about how the component that he's building, how it fits into the big picture. Those are all things that I wish in an ideal world that would be happening, and I want collaboration between testers and developers about making sure that we're building the right thing. Because it's a lot easier to build the right thing and engineer a product with quality than it is to test it at the end and try to reverse all that work. It's a lot more costly the later down we find issues, right? So you get early feedback on quality. Also facilitates changes. If you're writing these small unit tests and building up your suite, and then you're continuing to modify the program, it's continuing to evolve, you can rerun those tests as you make a change, and it can tell you whether or not the change that you introduced broke something that shouldn't have been broken, right? Also easier to integrate, right? If you have two small tests that you run and they work together, and then you bring them together to integrate, then at least you have some confidence that in isolation they were working, so there must be a problem with the connection between the two things. And then unit tests also serve, if you do them correctly, as a nice form of documentation, right? So remember, we looked at the whole idea of testing by looking, we looked at the code, and we said that if those variable names and if those function names were meaningful, it would describe what was happening from the code level. Similarly, if you have unit tests and your names of your test methods are descriptive and your code and the variables within the test are meaningful, it also helps to describe the test and the expectations. So they serve as a wonderful piece of documentation, and it's living documentation, right? Because once you do unit testing and you automate that test and it's there, it evolves with the code. So as the code changes, it is kept up to date. It's not like the documentation that sometimes we struggle to keep it up to date. It has to get updated, because if not, the program won't compile so that the test can run, et cetera, et cetera, et cetera. Right? All right, so unit test automation is where we're going to focus on. I'm going to go through some definitions first, and then hopefully we'll look at some practical examples, just as we have been. Again, if you're not computer science background, don't get scared. If you're not a programmer, don't get scared. Actually, there's a lot of power with different perspectives. So I like the fact that we have accountants and mathematicians and electrical engineers that helps everyone to bring a different perspective so that we get a better outcome, right? If we had all just computer science people, this would be very boring, right? Because computer science people are boring, right? No, that's not what I meant. So, all right, so the unit test validates the basic units of the program in isolation. The basic unit that you'll encounter most of the time in modern programming or object-oriented programming is the idea of a class, right? How many people are familiar with classes in programming? This my computer science. Oh, some other people too. Great. So we all know that these things are made up of classes. So if I ask you what is a class, what would you say? What is a class? A group of similar objects. I like that. That's great. It's a nice formal definition. I love when people give some formal-like definitions, right? But then you have to break it apart. What are objects, right? And what is that? What is the next thing? A class is just some abstract data type. And as you said, it represents a collection of objects or a group of objects that have some similar properties or characteristics. But a class is just really an abstraction that helps us to generalize the real world, which contains objects, right? Model the real world. So if you ever were wondering, like, why are we using classes? What does this all mean? Is that usually the approach to problem solving is that you think about the real world problem that you have. For example, at Ultimate Software, we build HR and payroll software and anything that deals with human capital management. And so we have concepts like employees. An employee is a class or an object in our system, right? And that employee may have a paycheck, right? All these things are things that we can relate to the real world problem that we're solving, and we can model that in the code, and we can build a solution that helps us to represent that problem in a very effective way that we can understand the problem and we can specify the solution, right? So, class is an abstract data type. It's an instance of an object. Sorry, yeah, an instance of an object is person. For example, a person, you can have an instance of a class as an object. And then once you run into thinking about specific characteristics of that object that's realized when you instantiate that class, you have things like name, age, person can marry to another person. So we start to see some of the things that we saw before with our functions, right? Those are just our operations. You can celebrate a birthday. And note that these operations usually act to transform some of the attributes. For example, if someone gets married to another person, depending on your culture, where you're from, if you're female, you may actually change your name, right? That operation may result in the attribute changing. Similarly, if you celebrate your birthday, your age has just moved. Well, for some of us, we're forever 21, right? But for others of us, we actually continue to age, right? So that's kind of the basic building block of a class, right? Unit test automation also requires typically the creation of what are called test drivers and test stubs or test mocks. Who's heard of this term stub mock in testing? Anyone? We don't want to put up our hands. Some people are like, yeah, we heard of it, but we really, we learned the definition and we really didn't understand what it looks like. That's how I felt. That's how I felt when I was learning testing, when I took my first testing course, and we were talking about these unit tests, the integration tests, and then they started talking about mocks and stubs, and I was like, yeah, sure. And I could tell people what they meant, but I didn't really know what it looked or felt like. Y'all feel like that? No, we're gonna demystify some of that today. But it's important to good to learn things in theory, but then what does it look like in the real world, right? All right, so we're gonna apply these things always. We're always gonna keep these things practical and apply them to the real world, correct? So let's think of a banking system. What are some objects, if you were thinking of a bank, like a commercial bank, we all have money, hopefully, at some point. And what are some objects in a banking system that you can name?
Client.
Pardon? Client, customer. All right, got the customer, thank you. Point one, all right? So you got the customer, what else is in the bank? What do you have a bank for? No one wants to talk, I'm gonna start picking people. Here we go. My friend here on your phone, right here in the front, sir. Hello? There we go. Don't worry, I heard that people like to go on their phone sometimes, so I gotta pull them off the phone. And then some of you are managers, so if you have an important thing, don't stop. But what do you think about when you think about objects that you would associate with a banking system?
Transaction.
Pardon?
Transaction.
Transactions, okay. So you can have transactions. And transactions usually operate on what? Accounts, right? Wonderful. See, got people back. I know it's going to be hard after lunch, but I have after the break, I should say, we haven't had lunch. Lunch is going to be terrible. Like, after people eat, like we're going to slow down. All the blood flow is going to go to our stomachs. There's going to be nothing left in our brains. We're gonna have a rough time after lunch. This is what I have my second tutorial. How many people in here are in my second tutorial too? Anyone else? Microservices? Oh wow. Yeah, I got another tutorial after this. It's gonna be after lunch. But I'm gonna try to make that one, ease that one in, right? Because can't start that one out with a bunch of code. All right, so transactions, you have accounts, right? So one of the things that we first just want to do in here before we start talking about how to test the units is understand how we can model a software system so that we can understand that if we're testing these units, we need to see what they look like. Just like how we had the engine and it was a whole engine and we broke it apart and we saw all these little pieces, we need to be able to visualize these pieces. That's one of the reasons why it's so hard for you to picture, you know, when you talk about unit testing or integration or stubs or mocks, is because we haven't spent time visualizing the code. We just see the code as text, and text is great, but it doesn't help you to see how things are working together sometimes, right? So, in a banking system, you might have things like a customer, my friend so correctly addressed initially, right? Hopefully you weren't cheating, right? You weren't cheating, right? Customer can have a name and an address and so on and so forth. And you can have operations like get name, set name, get address, etc., as you initialize those things. You have an account. An account might have an account number, a balance, etc. And there's a relationship, right? You can have one customer owning many accounts, right? So this is for my math gurus, right? So our association one to many, right? And this is an association that we just call ownership, right? Owns. This is my account, right? So far so good, right? See how like, this is all code, by the way. It's a program that I looked at and I abstracted the class model from it so that we can understand what's going on. And these are very, very important. And hopefully, if you have really good developers that like software design, you might see one of these someday coming from some of them, but typically you don't. But the good news is that you can develop a skill of being able to extract that yourself, right? All right, so you have accounts, and you can have two different types of accounts, right? Just for the purpose of this discussion, there's probably many more types of accounts that you can have. But in this case, you can have a checking account or a savings account. And these are two specialized accounts. And this notation here is the idea of inheritance, right? So for example, if we go back to the real world, as human beings, we inherit certain traits from our parents, right? So you might actually get an attribute from your parents, like your eyes or your nose or something. It's like, oh, you're Terry King's daughter for sure. You got his nose, unfortunately, right? And that might be realized in an attribute. It might also be realized in a behavior or an operation, right? Like I have a cousin that he walks and talks just like his father. And they actually look very similar, so it freaks me out when I hear him talking. Because it's almost like you clone this person, right? So he has inherited a lot of those behavioral characteristics that even when he does things, his operations, is done in a manner that just is exactly how his father would do it, right? And so this idea of inheritance, where you have a general thing, like a count, you can have two specialized things. And they really take on some of the behavior and the attributes from that parent. So you call account the parent class. This implies that every checking account has an account number and has a balance, right? So the child inherits those attributes from the parents. So we don't necessarily need to write them down here again, because it's implied by this notation that these children will have these operations and these attributes, right? But then there's also some special things. For example, in a checking account, maybe there's an overdraft limit, or there's some sort of service fee, or overdraft fee, or you can process a check, right? Whereas on a savings account, you don't process checks on a savings account. But now you might have interest, right? Some mechanism for calculating and paying interest. So that differentiates these two objects from each other, but they're both still accounts. That make sense? Awesome. See, this coding thing isn't that hard, right? You just need to have someone explain some things to you and then take your time and keep speaking that language. Are you okay, sir? You want some water? Are you good? All right. I know I stopped you from using your phone. I don't know if you're having an allergic reaction to not using the phone. Okay. just messing with you. All right. I got to keep us alive during this time till we get to the end. All right, so we have that covered, right? So we actually just learned the association between objects. We learned about operations and attributes. We learned about inheritance, which is another programming construct. You'll hear all these things as you interact with developers, right? And then you also might have a customer that writes a check, and that check might be processed against a checking account, right? So just another object that I'll throw out there. All right. All right, so as I mentioned to you guys, there's instructions in there if you want to set up any of the stuff that we'll see today, like as I go through the practical stuff, where it shows you how to set up your development environment, how to install values outside of that range, right? So it doesn't do this defensive check, like if the numbers outside this range do something. No, it's designed by contract. With defensive design, you're going to defend and protect from each of these things, right? So we mentioned that before. So there's a lot of benefits, right? The contract, and for example, if you think about a contract that you might sign in your life, for example, I bought a house 2 years ago. When you buy a house, you sign an agreement, right? Mortgage. Trust me, if actually you sign multiple times on multiple pages, you sign your whole life away, saying that if I die before I wake, I'll pay back all this money from my estate, right? Like, it's ridiculous, right? But with that contract, you get a benefit from signing that contract. So the consumer gets a benefit, but that benefit for the consumer is an obligation for the provider. In other words, I sign a loan, a mortgage, and I'm going to get, I don't know, $400,000 to buy this house, right? The bank has to, or the mortgage company has, that's an obligation for them to give me that money once I qualify for the loan, right? So the benefit for the consumer is an obligation for the provider and vice versa, right? The full contract for the provider is the sum of all the consumer contracts. So for example, if you think about that mortgage company example again, there's all of these consumers, people who are applying for mortgages. The sum of all the contracts is the obligation, total obligation that this provider has to give, right? The total sum of the money that they need to hand over to these folks, right? The reason that we're going through this and using this analogy is because this applies to the services, right? Each service may have a contract, right? Which the contract is about the inputs that it receives, right? And then the computation or the benefit that it provides once you fulfill that contract, right? And contract testing is really about looking at this whole idea of obligation and benefit, right? So how can we make sure that as we change things, the contracts are still being fulfilled, right? It'll make sense in a little bit, get clearer. So, you can test for contracts being satisfied. And one of the first ways that you can do that is that you want to focus for, if you're testing the provider, you want to make sure that valid inputs produce valid responses. Remember that we're designed by contract, which means that if I give you something valid, then you should operate and give me back, the correct result. So we have to validate in that way. There's no need in contract testing for testing the provider in isolation to test invalid cases. because you have a contract. If that contract is violated, you don't guarantee anything back, right? And so let's look at an example here. So let's see what we can do here. And we get to our coffee break in like 6 minutes, right? So let's say that I have a microservice that deals with checking account, right? So it handles accounts, right? Now, part of the process of that account may be actually withdrawing money. So this is the function, to withdraw, right? Part of my contract may say, because you're going to withdraw, and in here, this is an amount. My contract should say that your amount cannot be a negative number, right? Because withdrawing a negative amount is almost like a deposit, right? You don't want to accept a negative number, right? You want to withdraw $100, it's implied that you're going to decrement this thing. So you have somewhere in your code base some logic that talks about, you know, if the amount is less than 0. Somewhere you may have this in your code base if you are doing defensive design. In other words, defensive design says I want to protect myself from bad inputs. So it would check for that negative 100 in this particular class or service. If this service were not defined by defensive design, it was designed by contract, this code would not need to be there. And you say, but wait, like what if that happens? Well, the whole idea is that maybe what you do up here is that you have your inputs coming in here, this is your amount, and you have another service that really deals with making sure that that range, that negative thing never happens. And so therefore, when it goes here, you don't ever have to worry about checking it again, right? So if you have decided that you're designed by contract, your test does not need to worry about breaches of that contract.
But
right?
what if there's an internal system that goes directly to the checking account?
Well, then you have a problem, right?
Yep.
So if you have you're absolutely correct is that if you now go and take another service and point it directly to the checking account, then you have an issue, right? Then you either have to do one or two things. Since that service is designed by contract, you need to establish the contract with every particular consumer of that contract, right? So when you start talking about design by contract and defensive design, when you're doing testing, and we'll see this in a second, here, because we have a contract, we don't have to test for invalid inputs. It does not mean that we don't need to check that all of the people who are requesting they should be abiding by that contract. So you still need to check that, right? But you don't check it here, you check it with all of the particular consumers that are consuming it, right? And it'll become a little bit clearer in a second, right? But it's more like, if I had a test for this particular checking account and I'm designed by contract, then I don't have negative numbers there. But I have other tests that make sure that the providers never send negative numbers, right? Because they should never send a negative number, because if they do, then I have this breach and I could have a failure in the system, right? So contract testing allows you to write tests that validate or verify those contracts are being held, right? All right, we're getting there. So contract testing says garbage in equals garbage out. You know, if you don't follow my contract, then I don't guarantee you anything, You'll get back garbage and you'll have to deal with it, right?
Excuse me?
Yeah.
So then I think the contract has to be written very precisely.
Yes.
Precisely. Otherwise, you might miss something which they are thinking like it's understood.
Yes. The contracts have to be written very precisely, and there's tools, and we'll look at some of the tools for that to help you write those contracts very precisely, right? It's true. All right, real quick, testing the consumer in isolation. You have to test that each consumer, so this is what we were just talking about. You got to check that each consumer respects its contract. So you have your consumer contract, you can create a stub of the provider, and you just are trying to make sure, in that case, that the consumers are not violating the contract. So you check on that side of the fence, right? That's pretty straightforward. And then you invoke the consumer that calls this mock or this stub, this fake provider, because you just try to make sure that the consumers are sending the right calls. You don't actually care if it reaches an actual thing. But then you have to test the integration, right? So now you have to take the consumer and the provider, and you have to see if the consumer, while invoking the provider, have proper behavior. So just to summarize this, I know some of this might be a little bit deep for some people, but you have a unit level test for the provider, right, where you actually are checking or assuming that the provider is designed by contract. Then you need to check the consumers and that they're sending the right stuff. And then finally, even if you use some sort of mocks or simulations, you have to test these two things together. One of the biggest mistakes people make and folks make when they're doing kind of developer testing is that they use a lot of stubs or mocks to simulate things. And when you do that, you're already simulating or mocking away the real world. You still need to check, as my friend was pointing out, you really still need to check these things, how they're going to be shipped, right? Because there's nothing that replaces the real world system. Testing gives you information about the system operating in its real environment. So be careful with those simulations, right? All right, let's take a break. We deserve a break. Let's meet back probably in half an hour or so, right? 20 to 30 minutes, around there. So let's come back around 3:50, somewhere between 3:50 and 4. All right? Cool. There's a .NET version if you're interested in .NET. There's JavaScript, it's written in Go, there's Python, and you can usually find complete examples that show you how to use, how Pact is used and applied. And so there's actually code associated. So this is a Git repository here that has somewhere between unit and integration testing. It's kind of like a hybrid where you can do testing on the consumer alone and testing on the producer and then testing with the consumer producer. But you really have to get in and dig in to some of the content by looking up. And so if you go to this site, you'll be able to understand that, right? So,
question.
Yeah, go ahead.
So when you say contract in contract, does it mean the requirement that you're referring to here? What is
Well, it stems from the overall requirements, right? So for example, you know, if I'm building an application and that application deals with, I don't know, the number of hours in a week, then I may have a service that needs to conform to that contract, right? So what happens is that your requirements get realized into these contracts around services and how services interact, right? Because you need to validate data and information, and those usually come from the requirements or the problem domain. Yes, it derives from requirements. All right, so real quick, just some guidelines. So just for you that came in, I think I got the slide after this. We were looking at just a tool that you can use to implement this. But just some guidelines that I want you to follow. Consumers should define their own contracts. The provider should facilitate resolution to any contradictions among consumer contracts. So remember that you have all these consumers that each have their own contract. A consumer could have a rule or contract that contradicts another consumer. there's no way for the provider to resolve that without trying to reconcile these two opposing contracts, right? And so the provider should facilitate that resolution between those two conflicting contracts. As you update a service, the provider needs to execute the contract test on its provider. So if we change a service, then you rerun those things to make sure that the contract is still being fulfilled. And from time to time, you'll have behavior that changes in a way that violates the contract, right? And if you have to do that, the provider should issue a new version of the service that has a new contract, right? So whereas maybe some set of consumers are on V1, as you evolve, you may have to say, well, you know what, I still need to support V1, but for now, we also need to define a new version and has a new contract for the newer aspects of the system. And so it comes into maintaining these multi-version systems, right? That can become tricky because now you've got to be doing more testing, right? V1, V2, the combinations that go into that, right? All right, yes, sir.
Isn't it then, at the end, we are going into the same detail of requirements of the specification document? So our contract actually is becoming a requirement specification. Because all those details, everything, what we are assuming is in SRS, is eventually we are.
Not everything is getting trickled on there. It always goes back to her point, right? Which is like your requirements eventually get realized into these constraints or contracts in there. But it's not everything that's written in the SRS that becomes a contract on a service, right? Remember, your SRS defines the requirements from a high level. For those of you, that's just the software requirement specification. Our SRD, software requirements document, there's a lot of different words, or BRD, business requirements document. Those contain the high-level vision, high-level requirements. Some of those stay at a high level. Others, depending on if you're in an agile world, will get broken down into user stories and so on and so forth. But yes, some of those requirements end up becoming constraints, right? So they come from there. It doesn't mean that everything that's defined there needs to find a place on a service somewhere here, right?
So what if the consumer is not sure about those requirements?
Well, then you got a bigger problem than microservices. You have a requirements problem, right? Like you got to know what you're building. You have to know what you're building.
Have an overall view, okay, what do you want? Okay, let's say.
But you got to ask the questions and get them to. You see, like we build software, but we got to realize that if we have ambiguity in requirements, then you're going to build the wrong system, or you have the potential to build the wrong system. So you need to have those conversations to clear up that requirements, because it's very hard to, in all fairness, it's very hard to define exactly what you want up front. You know, that's why waterfall doesn't usually work, right? Agile doesn't necessarily always work either. But the whole point is that we have to iterate and go back and say, like, hey, we don't understand how this is supposed to work. So we don't know what business rules are around it. And have that conversation and then come back and then do that again, right? So, all right, so for those of you that missed it, I know some people came in afterwards. This is the website that we're looking at, docs.pack.io. That'll give you a good frame of reference for contract testing. Because the point that I really want to get to here, we're going to gloss over the defensive testing strategies. It's just heuristics as well. But I really want to get to integration, because integration of services is something that most folks don't focus on. And so that can provide you a lot of value. A lot of the contract testing stuff is out there, so if you needed to go look at it. But where the folks at our organization really struggled with was understanding how can I integrate. And I want to show you that some of the things that you've been learning, things like pairwise testing and other approaches, can be used to help you do integration on services, right? So real quick, for the defensive design, defensive programming stuff, you do need to test using valid and invalid inputs, because remember, it's supposed to defend from invalid inputs. And for your consumer provider integration, you need to test that the consumer handles all the error responses that are generated by the providers. And then there's an impact on the code when you do defensive design, right? You're going to add all these checks. Remember, we talked over there about if the amount is less than 0, you're going to have all these checks in the code. That'll grow your code base. but it improves security, but it can reduce the performance, right? You might have to do more optimizations and so on and so forth. All right, so the next category of testing is service readiness. So the first thing that I told you is that these services have to be independently deployable, and we spend a lot of time talking about that. But what it means is that you need to have a testing strategy that looks at aspects of whether or not that service is ready. And what does it mean to be ready? Well, the first thing is that you have service management, right? Does the service actually start up, shut down, and restart in a graceful manner? You have to have tests for the services around that. What about the service health, right? So is the service up and running? And are its other dependent services also up and running, right? Then logging and auditing, so we talked a little bit about monitoring. You want to find out if the service is actually recording things from the implementation level as the service operates, right? There's a lot of logs that can spit out from the implementation, or from the domain level, right? With respect to the problem events. And then error handling. You have to have testing around, does the failure retries or any fallbacks actually behave as expected? So whereas before, like I said, before we moved to microservices world, some of these things weren't as much of a concern. Now these things are very specific to microservices, and we have to start thinking about those pieces, right? All right, integration. So this is where we'll have some fun, right? And I'll get you to apply some exercises so that we can use our brains before we lose everything that we have. So we're going to get to the end. Hopefully we'll wrap up around 5-ish or so. But you have this idea of a bounded context, right? In microservices, a bounded context are all of the services that are required to fulfill some aspect or transactional boundary, right? System boundary. And when you start thinking about bounded context, you have to do testing within a bounded context because there are services that talk to each other, but you also have to look at interbounded context, right? So when one application is calling another application that also has microservices, right? And these could all be applications that your organization is building out. For example, Ultimate Software, we build HR and payroll software. Now that sounds like, oh, that's just an application. No, it's actually a suite of applications, right? So we have a core application that deals with human resources and running payroll, but then we also have a recruiting application. That recruiting application is used to integrate with things like LinkedIn, so you can send your resume and recruiters can determine if they have viable candidates that they can bring in to interview. And then if you recruit someone, you may eventually want to hire that person. So that integrates into our core HR application. If that person gets hired, then you need to onboard them. And so there's another application that deals with onboarding. So all of these things are bounded contexts, right? Because you can think of them that they solve a specific problem and everything that's necessary to solve that problem, but they all need to communicate and integrate with each other, right? So in the microservices world, you want to start thinking about all this complexity, right? This is why people freak out, right? Because first of all, just for one application, you have all of these microservices, right? And then you need to put API wrappers and gateways around them and so on and so forth, which is good because you can communicate, you can reuse, there's a lot of benefits. But then if you build everything in this way, this picture shows you how much testing needs to go, right? So there are some approaches that you should be familiar with, at least one or two of them, that can help you to reduce this complexity, right? Because when you start looking at that amount of services, then how do you really reduce the amount of combinations and things that you need to test? And you already know at least one of them is very popular here. It's taught in the ASTQB piece, which is pairwise testing, right? How many people, was there a tutorial, I think there was a tutorial or something on pairwise testing? Anyone attended that one? No? How many people are familiar with pairwise testing? At least, no one? Wow, okay, so maybe I assumed wrong. There was a tutorial on pairwise testing that was taught by Rex taught one. So that's something that you should look at. Don't worry, you don't need to have prior knowledge of it. We're going to talk about it here. But we're going to go through 3 different ways to actually do microservice integration, right? So the first one is called integration test ordering, right? And so the purpose of this, and this comes a lot from academia, where it looks to find an optimal order for doing integration tests that can help you to reduce how many mock services or stub services you need to spin up, right? And what it says, the assumption here is that developing mocks or having to create mocks when you're doing integration is very error prone and time consuming, right? People could make mistakes, or it just doesn't really represent the actual service. You're creating this fake service. And so the techniques that you can use is to either try to minimize the number of mocks that you have to create, or the number of stubs, or the number of, or the complexity of the stubs that you have to create. So maybe you might have to create more stubs, but you at least have the simpler ones, right? So these are 2 approaches. And so how does this work? Well, the first thing, let's go back to our example where we have all these services, right? If we want to reduce the number of stubs or mocks that we need to create, right? Because for example, here, if we were going to test trip management, well, trip management depends on billing, and trip management depends on notifications. So if I were to try to test trip management first, I would have to create 2 mocks, right? But if I started with notifications, it doesn't depend on anything, right? So I don't have to create any mocks for notifications. So you can see how this can become a graph problem that you can optimize on. If you look at the dependencies here, then I could do things like I can start from any one of these nodes that doesn't have a dependency, and I should start testing there, right? So for example here, I could start with any of the 3 of these. Now that I've tested this, this, and this, like they're all independent of each other there. So I do billing first, then I do payments. And now that these 2 are done, I could test this guy, right? But because now that these 2 are done, for example, payments was the only dependency that this had. So now that I've tested it, I could test him. But I'll just continue and test notifications. And now that notifications is tested, then I could test trip management, or driver management, or passenger management, right? So the whole idea is to start testing the leaf nodes first, and then as you test those, then anything else that depends on those nodes that you've tested can also be tested. Everyone follow that? So we could build this out, 4 or 5, then you could do 6, and now you do 7, 8, and 9, right? Now this is just one possible ordering for this. There could be another possible ordering. So this is an alternative solution where instead of doing 1, 2, 3, I first did 1, and because I could do this, I did 2. Then I did 3. I just kind of chose random here, 4, and I went through. This is also a valid solution, right? Because I still minimize the number of stubs once I do this. For the math people, this is just a reverse topological ordering on this graph, right? Sounds like a big fancy word, right? It's not that fancy. All right. But y'all know a lot of math, right? You do a lot of math in this way. See, y'all probably know more math than I do because I don't really like math that much, right? Or I don't know. Who knows? I guess I did the PhD and I had to figure out some math for that. All right. So that is called integration test orders based on dependencies, right? That's one approach to dealing with microservice integration. All right. So the next one is called pairwise integration. And what you want to do is limit testing to each pair of microservices, right? And so you can have one integration test per pair, right? Per edge in the call graph. And what you can do here is that because you will have these pairs, here you're not necessarily caring about stubs, so you don't actually create any stubs. You can reduce the stub overhead by just ignoring stubs and just focusing on testing these integration pairs, right? And I'll show you what I mean in the context of this example too. So here, you have services that are connected to each other by edges, right? Your integration test order that uses pairwise may start to just say, well, let me test the communication and the interaction between the API gateway and passenger management. And you have a test for that. You can then move on to do this, and then this, and then this. See a pattern going here? So we just systematically go through all pairs of services that are connected to each other, right? And that pairwise method or pairwise methodology is something that usually can help us to get coverage of connections to things. We talked a little bit about the fact that you can have units that are working, but then these services are not talking to each other properly. If we did pairwise, then we can make sure at least that we tested each edge at least once, right? And that may not be the full list of coverage, but at least it gives us some confidence that we've at least done some testing on each edge, right? Cool, we're powering through. Soon there. The third approach, when I was in school, I really loved this graph theory stuff. Like, I don't know, some people like it, some people don't. But I remember sitting in class when we were doing the analysis of algorithms. You know, you go through all this stuff, you get headaches, you finish it or whatever. But in the beginning, before he got to the graph stuff, I was like, this stuff is really, you know, a lot of different approaches. And then he put up the graphs on the board and started talking about the graphs. And I was just like, oh yeah, that was fun for me, right? Because it was I don't know if it was visual or whatever it was. But these approaches are really and truly, like when you think about testing is a lot about coverage, right? We talk about coverage of this and making sure that we cover each requirement. All these things can just be translated to graphs and coverage of nodes on the graph, right? Maybe that's why I like testing, I don't know, but I don't draw graphs for everything in testing. But you can see, as we talk about different things in here, like you can represent almost any aspect of software as a graph, right? In the white box class, we talked about control flow, we talked about class diagrams, talked about all these things. These are all just connected graphs, right? And here the same thing when we get to microservices, right? Just a connected graph. And so all of the knowledge about graph techniques can be applied to these things, right? So you take one problem and you map it to another. So the last one is something called neighborhood integration, which is pretty cool, all right? Neighborhood integration says the neighborhood of a service is the set of services that are one edge away from a given service.